Ladies and gentlemen, this is the Tecumseh AB 5524F compressor that came out of my beloved KeepRite ICP air conditioner. So I got the old girl hooked up to power here. Don't really have 240 volt outlets sitting around, so I'm using that trick of using two opposing phases to get 240 volts. Very dangerous, don't do it at home, not recommended, and it's only on a 15 amp fuse, so there's a good chance that it could blow. Also, it's using the original contactor with a 24 volt transformer to power the contactor coil. So there's actually 3 plugs you gotta plug in to get this working. So let's give it a go and play around with it. It is grounded too, by the way. It's not, you know, the most, the nicest looking ground in the world, but it works. It gets the job done. So let's plug it in and see what it does. Oh, that's a lot of oil. Good vacuum. Oh, that's a lot of air. Wow. Wow. There's that beautiful sound I remember. This thing pumps out a ridiculous amount of air. This is way more powerful than the fridge compressors, obviously. Not run it for too long. It doesn't have any subcooling coming back to cool down the motor. I can smell something burning. Or maybe that's just compressor oil. So I've put a clamp meter on it while the contactor is off to see how much power the crankcase heater start winding is using, and it's pulling 2 amps. Let's just say 2 amps. So that means it's using about 480 watts all the time, unless there's like some inductance or reluctance or some shit that I'm missing here. But if we just go by straight real power, then this thing is using 480 watts all the time. That is really power hungry. Huh. Even in the winter when the AC is off, huh? Very interesting. I'm going to put the camera on the compressor and see if you guys can hear that humming noise that I hear from the start winding. Don't know if you heard it this time, but that is the crankcase heater. The crankcase heater. When I was a kid, I used to play around with the air conditioner's thermostat a lot, much to my dad's anger. And it was one of those old mercury thermostats, you know, the ones with no electronics in them at all, just like a little blob of mercury in a glass tube. So basically, I used to love the sound of the AC's compressor building head pressure, right? When it would start up, it would be very loud, and then it would quiet down until you couldn't hear it anymore. And the sound was kind of cool because it used to like shake the house right when it started, but then it would be totally silent after. So I used to, you know, turn it on. Once the sound went away, I would turn it off again and immediately turn it back on again, hoping to hear the sound. But when I did that, obviously, now there's pressure in the system and the compressor can't start under pressure because this doesn't have this is not a capacitor start unit. It's a capacitor run unit. Or it doesn't have a hard start kit, rather. That's pretty much what a hard start kit is, to my knowledge. It's just a start capacitor. So this couldn't start under pressure, and the fan would start turning again, but you wouldn't hear the compressor at all. And then after a few seconds, maybe like 10-15 seconds, the compressor would come back on and you'd hear the head pressure building again. And I would repeat this so many times because I was a stupid dumb kid. And after all these years, after all that abuse, this thing is still fine. So I'm curious to open this up and take a look at the motor windings and see if they're burnt up at all. I've actually heard rumors that the windings in this are like 14 or 12 gauge or something crazy like that. So we'll see. We'll see how much truth there is to that. Oh, and yeah, I think the thermal overload device is defective because, well, it never actually stopped the compressor for any significant period of time. I don't think it stopped the compressor at all. that time when that time when it was in silence, not running, I'm pretty sure that it was just sitting there humming, like trying to fight against the pressure until it finally reduced enough that it could start turning again. I don't think the thermal overload ever intervened during any of those times. Because I've seen a thermal overload kick in on a fridge, and usually it's like a good few minutes before it kicks back on again. Anyways, let's power it up again and see how the current changes while it's running. And when it's under pressure, when it's under vacuum. That's not a lot. 4.6, 4.5. Goes down as the vacuum is pulled. That's expected. Put it under pressure, it should go up. You gotta be careful with that, that's a lot of pressure. Let's unplug it. Yep, crankcase heater. Crankcase heater is energized again. Damn, that's a lot of power. I was expecting this to only pull like 1 amp or half an amp or something. That's crazy. So I got the compressor cut open. And I forgot whether you were supposed to cut above or below the weld mark. You're supposed to cut below the weld mark. I cut above the weld mark. And as a result, I realized I was doing it wrong, but then I just said screw it and I kept going and I contaminated all the oil with metal shavings. Whatever, this compressor's not going back into an AC anyways. Now all I gotta do is ohm up the windings and see which is which, because I also pulled this off without taking a picture or anything because I forgot. Oh, also I opened it like 2 nights ago, which is why the inside of the shell's already starting to rust. As you can see, the motor's pretty big. The stator is very square. This is actually pretty compact. The piston and cylinders down the bottom, I'm guessing this is going to be a 2-cylinder. Thermal Klickson device up here, interestingly enough, not touching the windings directly, so I don't think this is influenced by the heat of the motor itself, but rather the amount of current it's drawing. And as far as I know, this doesn't even work properly because, like I said, I've overloaded this compressor a bunch of times in the past, and this thing never really intervened. I prefer these things to be on the outside of the compressor, so if they go bad, you can replace them. In here, you'd be screwed. And also, it's interesting how they use spade terminals, which is not the most secure connection in the world, but, I mean, this has been holding up after all these years, so who the hell am I, right? And also, if you look around it, you can see that I'm pretty sure that's the intake. That's got to be the suction. And, of course, discharge through the muffler down the bottom, loops around to warm up the crankcase oil. And then it comes out over here. It goes into your condensing coils. And suction line is over here on this part of the shell, which means it would be over here approximately. So that means the cold suction gas returning, the subcooling returning, would have to pretty much flow around the entire motor and through the windings to get back into the suction line on the compressor here, the intake of the compressor. So very smart way to cool a compressor down. I think they still do this with scroll compressors. I think rotary compressors are the opposite. I think the hot discharge gas actually goes through the motor, which is a little strange and maybe why they don't last very long, but you know, whatever. Also, I accidentally cut through the spring mounts, or I broke them off or something anyways. I broke 2 of them. So the motor is just hanging off one, but these were originally not broken as far as I can tell. This was my fault. That was all my doing. But yeah, once I turn this on, it's going to make a hell of a racket because it's going to be jumping around, but we'll see. Not going to run it for too long. I don't want those metal filings to ruin it because I do want to open it and see how much wear it had on its own after all these years. Alright, so let's ohm up the windings. I got the meter set to ohms here, and I've determined that this one here on the right is common because it's going into the Thermal Klickson device, and according to that wiring diagram that we saw before, the Klickson device is connected to, or the thermal overload device rather, is connected to the common. So If we stick this in here, we get 4.3 ohms. So that must be our start winding because it's pretty high resistance. And let's check this one. 0.9 ohms. So that's our run winding. So our run winding is the striped red wire and our start winding is the plain wire. Our striped black wire is our common. Okay, that makes sense. Let's wire it up and see what it does. Ladies and gentlemen, here we have the pump and motor from a Tecumseh AB series reciprocating compressor from my old KeepRite SSC 241D. One of the most overbuilt, most durable air conditioners ever made under the frozen sun. Obviously I've drained all the oil. I have it in this tray, which actually apparently has a leak in it. And well, due to the way I cut the compressor open, I forgot that you were supposed to cut above the weld mark. Or was it below the weld mark? See, I'm forgetting again. You gotta cut somewhere where I didn't cut. And as a result, I've contaminated everything with metal shavings. Now, I hope that didn't damage the compressor for the short period of time I ran it in that last clip. I don't think so. But yeah, that's good mineral oil. It's not burnt out. I mean, yeah, it's contaminated with metal shavings, but it smells okay. And it tastes pretty good, so that's good. I have no doubt that this compressor is perfectly healthy. Well, it was fine. It's just that the system leaked. That's why we had to get rid of it. But this thing, the reason I'm taking this apart today is to prove that this thing could have lasted quite a bit longer had it not been for the leak. Because a lot of people tell me, hey, that old AC is old, so it could go out at any time. But you know what? I have faith in good old-fashioned American steel. And today I'm going to take it apart. And I have faith that the bores and everything are perfectly fine. The bearings are all okay. I know that this is solid. I know the motor is good already for sure. Nothing wrong with that. Today we're going to be taking a look at the pump and seeing how worn out it really is after 41 years of work. There we go. It's like it was meant to be. And the best part is that it even fizzes up. If you shake it, the R22 that was migrated into the oil starts coming out. So, time to put this back in the fridge for some unsuspecting fool. Well, let's have a look at what we're dealing with here. So, first off, these spring mounts were mangled by me. They were actually fine before I opened this up. And this compressor is interesting because normally the compressor is supported from the bottom with the springs pushing up, but this is like a, it hangs on these springs instead of being, floating on the springs. So that's unique. It's not like those old Copeland reciprocating compressors. Here we have the intake. You can see that it's really wide and the mouth is aimed at the top of the motor. And on the compressor shell, the intake or the suction line would have been around here somewhere. So a lot of the suction gas would have had to pass through the motor before entering the intake manifold. So that's a smart design that kept the motor cool. Now moving here into the crankcase section, here you can see the two pistons, the crankshaft, the big end bearings, and what appears to be some kind of slinger over here. I think this is some kind of oil slinger, but this does have an oil pump too. Not a very high pressure oil pump, but it doesn't really need it. This is the oil pump, or the oil pickup. Now, I'm not entirely sure how this works, because it could be different, but from my knowledge of refrigeration compressors, at least the simple ones in fridges, usually there's a spiral baffle that runs down the crankshaft, right? And as it spins, it picks up the oil from the bottom through the spiral cutout, and then it comes out through, well, all the bearings and things that need to be oiled. Like, for example, here you can see an oil hole. This is likely where the oil gets slung out after passing through the bearing. As you can see, it lines up in only one spot here. That's probably where the oil comes out. And looking here, nothing looks too badly scratched. I do see some score marks. That one I can't really get that good of a look at. But everything seems to be fine over here. Now, one thing there is to note is there's a bit of axial play on both of the pistons, on both of the big end bearings. But as far as I know, that's not really a concern. There is no play this way in the radial direction, as far as I can tell. So that's the most important thing. This compressor wasn't knocking or anything. It wasn't loud. It was actually exceptionally quiet. Yeah, it's turning all smoothly and everything. Moving on to this side. This is the cylinder head, obviously. Now, I don't really have a socket for this. I'm going to have to figure out what to do about that. Maybe I'm going to have to cut slots in them and open them with a flathead, but they're probably super tight. Not sure what that is. That might be some kind of pressure relief valve or something on the discharge in case it overpressures. It very well could be. I'm not sure what that is either. That might actually be where the air comes out, or the gas comes out from the pressure relief. Here we have the discharge muffler to keep things quiet, and then we have the discharge line that actually loops around the bottom of the crankcase, which I guess is to warm up the oil even more than the always-on crankcase heater. And as far as I remember from the fridge compressors, the Tecumseh fridge compressors I took apart, there was a thing that looked like this that was an intake manifold type thing, and that one would be the discharge manifold. I'm not too sure. We'll see about that. And this compressor has two bearings. I think it has two bearings. I'm not sure if this front one is a bearing, but I think it's a bearing. And then there's one main one up there, and then nothing on this end. That's how they put compressors together. It saves space, I guess. Yeah. So let's take a look at that. Wow, look at all the metal shavings that got onto the windings. And I ran it that way. It's a good thing there wasn't a short circuit or something. That could have been bad. So I've taken this little plate off the bottom of the oil pickup to reveal something I didn't expect. Now, it's got like cutouts and things in it, and it's even got a gasket. Now, I was under the impression that this was like a spiral, oh yeah, flathead screws, and they had like a dimple pushed into them to lock it in. So that was kind of annoying to get out. Flathead screws, what year is it? Oh wait. Now, two things I want to note here is when I turn the crankcase, you can see that that oil that's there is getting sucked in slightly. So that tells me this might actually be like a positive displacement oil pump of some type. Maybe it's like a gear pump or some shit like that, or a trochoid pump. I don't know how you pronounce that. And unfortunately, there's a metal shaving jammed in there. I'm like 90% sure that's my fault. I'm like 100% sure that's my fault from the botched cutting job on the compressor case. Hopefully nothing more has gotten in and ruined everything, because, well, that's kind of going to skew my analysis results for what I'm trying to prove here, but whatever. Anyways, I'm very curious to take the rest of this apart and see how this oil pump works. And I wonder what these passages are for, too. It looks like it, actually, yeah, so that means it connects this hole to this one and this one. I wonder what that's for. I guess we'll have to take it apart and find out. Now, here's a bit of a throwback. So I just turned this bolt, and a bunch of refrigerant and oil just came out of it really quickly. Now, if you go back and look at one of Aussie 50's old videos, rest in peace, by the way, Aussie 50 was a great guy. This is where, he's where I learned all this stuff from. Awesome guy. Sucks that he did what he did, but that sucks. Lots of lessons learned from that man, and here's one of them. So I am actually wearing safety glasses, and the reason why is because from what we learned from one of Aussie 50's old videos is that refrigerant can slip into the tightest of places and migrate in there. So when you open these, there's a chance that the refrigerant will rush out and spray you in the face with oil, possibly blinding you. So always be careful in that respect, because that was a lot of refrigerant trapped under that. Okay, I'm pulling the oil pump off, and I'm doing this on video just in case something falls out and I don't know how it goes back together. And oh, that looks like a big brass bushing. Oh, that does look terribly worn out. I wonder if that has to do with what I did to it. It doesn't feel bad though. It's got a lot of scoring on it, but oh yeah, that's got a lot of scoring too. I feel like this has to do with what I did. I feel like this is my fault. Or is that copper? Should be brass, but also, why does it look so... Oh, that plate came off. Should we put that back on and see how much play there is? Oh, it's not bad at all. That's fine, that's all right. There's no wobbling, that's good. There's that metal shaving. I need a smaller screwdriver for this. Yeah, that definitely looks like one of mine. I don't think that was natural. Okay, I think it is just the normal spiral baffle type oil pump. I don't think it's anything special. Not quite sure why there's a hole in the center separate from that one. I believe that one there is the oil pickup, and I think that one is just another journal that's fed through this thing. No, yeah, that's what it is. And then that hole there, I'm assuming oils this bushing here. Everything was smooth, so I bet this would last a good long time still. Okay, I opened these things, and it looks to be... Yeah, I think that's the intake, but when I block it off and spin it, it doesn't build any vacuum, because I guess those two, the hole back there that I can't reach is interconnected with this one. And same thing for what I think is the discharge manifold here. Actually, if we look at the back of that, it reveals nothing, so never mind. This one here was like loaded full of oil. Now with these off, it makes quite a bit more noise when I turn it. Oh, that's a lot more play. I never noticed that with the front bearing cap thing off. That's a lot of play. But that is with this off. It wouldn't normally run with this off. Here we have the compressor pump all disassembled. I took the stator off so I can scrap it later. Getting the head off was an absolute nightmare because I don't have the correct tool for it. It's some special bolt, like, you know, those corrugated ones, whatever the hell you call them. I had to do all kinds of things to get them off, and as a result, my my whole thing where I wasn't gonna, you know, try to contaminate anything, I just said, screw it, and I did this. And I got it off. It wasn't too difficult. Actually, it was pretty difficult. Anyways, let's take a look at the valves. So these are the intake valves, and they're moving pretty freely right now without any spring pressure because they actually have to be, you know, slotted in over there for the appropriate pressure to be applied on them. And as for the discharge valves, which are now covered in metal shavings, they appear to be fine. Well, they probably were fine. Why am I even doing this? It's a waste of time at this point. Okay. So the compressor pump, this still turns freely, and I've put my hand over both of these and then spun it and moved the piston down to see if it pulls a vacuum. And it does pull a vacuum, and it holds the vacuum, which means the piston ring and bore are fine. The bore still has the factory cross-hatching with no vertical scratches on it or anything. Well, there are now because I got metal shavings in there and spun it a bunch of times, but trust me, when I opened this, they were absolutely perfectly clean with the factory cross-hatching and everything. Like, this thing had like no wear in the bores. So, very little wear on the connecting rod going, you know, radially, which is the most important dimension, I think. And the bores were good. So this compressor easily, I think, could have gone like at least another 15-20 years. No problem, this old thing. These things were built to last. They don't make them like they used to. Let's get the pistons out and have a closer look. I assume I'm going to have to get that retainer ring or slinger or whatever off. But yeah, full confidence that this thing could have lasted a longer time if not for that leak. Alright, well, at some point I kind of decided that I'm done being careful. Let me know down in the comments if you figured out when. Anyways, this is one of the pistons. I couldn't get them both out. As you can see, interestingly enough, no piston rings. I thought this would have like a rubber piston ring, like some fridge compressors. But no, it just seems to be like an exact machined fit with the bore. That's how it keeps a good seal. That's very interesting. I wouldn't have expected that. I thought there'd be some kind of piston ring in there, but nope. These things were empty when I pulled them out. And the small bearing is good. There is some copper dust in there, interestingly enough. And this thing was covered in copper dust too, which probably came from this bearing. Well, maybe it's bronze. It looks copper though when it's in the dust form. That explains why this thing is this color. This is completely covered in dust from the bearing. So, yeah. But, by the way, this bearing is, like, it doesn't look great, but none of the scratches catch your nail, so it really wasn't that bad. That was fine. The big end bearings were fine before I did that too. They were perfectly okay before I did that, and that one's completely ruined. I did that too, obviously. You guys saw this a few minutes ago. It wasn't like this. I just lose my patience pretty quickly. I don't have the right tools for this. Also, I'm pretty sure these pistons were never really meant to come out, because this rotor was pressed on afterwards, so you can't take the crankshaft out. Anyways, I think that just about concludes this extremely botched teardown of the Tecumseh AB compressor. Oh yeah, I got pretty mad at one point. Yeah, it kind of feels bad doing this to such a trusty old compressor that served me well all this time, but you know what, it's going in the trash anyways. Anyone wants to argue with me in the comments, go right ahead. Anyways, thanks for watching and have some fun under the reciprocating sun.